So here's example 1 for average pressure loss method. We're going to use copper tubing as our material. So we're going to stick to the recommended velocities, 2.4 meters for cold, 1.5 meters for domestic hot water. A couple conditions here, some service losses, etc. We're sizing from the PRV out, so what I'm concerned with here is the PRV set point 510, elevation loss 8 meters, so we're going to have to multiply that by 10 kPa per meter, so we've got 80 kPa loss due to elevation. Developed length is 30 meters, so we'll figure out our equivalent length from that. And then here's all our fixture specifications. We'll be able to get those loads from table 2632A. Okay, so here's our calculation based on the specifications for this project. There was 810 available at the property line, 30 kPa lost for a little bit of friction in the service line. So 780 was available to the building. The 270 pressure drop or 270 pressure difference was calculated because we have 780 available to the PRV. The PRV has a outlet set point of 510, so the difference there is 270 kPa pressure drop or loss from the 780 kPa. Losses for system height, of course, was the 8 meters times 10 kPa per meter, and here's our minimum 105 kPa or 15 psi for fixture operation. So once we've made all those deductions, we come up with 325 kPa left over. Divide that by the equivalent length of our system. We had 30 meters developed length times 1.5, and we've got 7.2 kPa per meter available, so no problem. We should be able to use the table without any issues. Okay, just looking at all our loading here one more time. I'd like to point out that these 4 suites, these are typical here. These would be private loads for those fixtures in those suites. And then we have some sort of communal space down here. We've got some hose bibs, we'll call them public hose bibs. There's a service sink and 2 clothes washers down in a laundry room. So that's for use by all the occupants. We'll go with public loads for these fixtures, private loads for the suites. Okay, so service sink with a 1/2 inch rough in. All these loads again taken from table 2632A. So under sink service, we see 3 fixture units going with 100% loads. A 3/4 inch public hose bib is 6 fixture units. And the clothes washer is public as well, 6.8 kilogram capacity type, that's 4 fixture unit. These remaining fixtures are the private loads. Lav 8.3 liters per minute maximum, so that's 0.7 for the hot, 0.7 for the cold. Flush tank water closet, 6 liter per flush is 2.2. 1/2 inch bathtub is 1.4, and the kitchen sink is 1.4 as well. Okay, so on the average pressure loss sizing table, this is again for distribution lines, we'll be using the column for 2.4 meters per second for any cold distribution lines and 1.5 meters per second for any hot distribution line. Again, we're using copper for this installation. Okay, looking at some of our totals here. A was our kitchen sink. Again, kitchen sink we said was 1.4 for hot, 1.4 for cold. We always go with 100% load. The load for A is just the 1.4 fixed units. The meters per second, A is a cold line. These solid lines are cold lines, so 2.4 meters per second. But it will be sized directly from table 2632A as a supply pipe. We have a couple of supply pipes here. A is a supply pipe for that kitchen sink. B is a supply pipe for the flush tank water closet. So we're just going to go with minimums here. They are not distribution pipes, they're supply pipe. B, 2.2 fixed units, 2.4 meters per second, 3/8 size as a supply pipe, again, directly from table 2632A. And then the remainder of this installation will be sized as distribution from table A26312F. So C, we have a hot line supplying the upper suite, 1 bathtub, 1 lav, 1 kitchen sink. So that's a total of 3.5 fixed units, 1.5 meters per second, and looking at the table, 1.5 meters per second, up to 3.5 fixed units I can accommodate on 1/2 inch. So we can go 1/2 inch for pipe C. So again, all of these now, the remaining pipe sizes will be from the average pressure loss sizing table. So D is a cold line supplying the upper suite. We're going to pick up a flush tank water closet as well. So we have a total of 5.7. It's cold at 2.4 meters per second. And off the table, we'll have ½ inch. E is hot line supplying both the suites there on the right. 7 fixed units at 1.5 meters per second. So for 7 fixed units, we're going to need 3/4 inch at that velocity. F, 11.4 fixed units. It's the cold for both suites. 2.4 meters per second, and according to the table, 3/4 inch. Okay, so I think we're getting the hang of this. G, 11 fixed units. It's hot, so 1.5 meters per second. I get 1 inch. H is 17 fixed units. 2.4 meters per second. It's cold, so that's 3/4 inch. I, 17.4. We've got the 2 suites to the left plus the hose bib. 2.4 meters per second, 1 inch. Now J is the total hot leaving the tank. So for the hot, we've got 2 clothes washers, and our clothes washers, all these public loads down here, our clothes washers were 4 each. So 4 hot, 4 cold for the clothes washers. The service sink we said was 3. Of course our hose bib is 6. Fill in this other clothes washer. So for G, we said was 11. E was 7, which is the same on both sides. So for the total at the hot water tank, we should have 25 fixed units. So that's 25 leaving the tank, 25 supplying the tank at different velocities. So J is 1.5 meters per second for 25 fixed units. That's 1.25 inches. But K, same load, different velocity, 2.4 meters per second, is 1 inch. Okay, and then we get to L. Remember, the load upstream, immediately upstream of a hot water tank, is the load of the tank. So here's our total for L. Hot water tank is 25. Plus we need to add in the load of any fixtures that didn't already show up in the hot water tank once. So cold only fixtures, hose bibs, flush tank water closets, that type of thing. So we have 4 water closets, which is 8.8, and the 2 hose bibs, 6 each, so that's 12. So for the total at L, hot water tank plus all the cold only, we get 45.8 fixture units. Cold distribution, so it's 2.4 meters per second, and from the table, 1.25 inches.